So the topic which we're going to do is the topical past paper of electrolysis. In the electrolysis, you have already studied that they are the two terminals. One is known as a cathode. This one is a cathode here, and the other one is a anode. This one is a anode. Okay. So the two terminals. These are the two terminals which are connected with the battery. These are the two terminals which are connected with the batteries, and these two rods are known as electrodes. So the electrodes are of two types. One type of electrode is known as inert electrode. The one type of electrodes are inert electrode, and the other type of electrodes are the non-inert electrode. Okay, the inert electrode are used for the extraction purpose. Okay, the inert electrodes are used for the extraction of metals. Okay, we go for the extraction of a metal, so we will use the inert electrode. Okay, and the extraction of a metals, like the extraction of iron, aluminum from aluminum oxide. In your course in the metal, you have studied that the extraction of metal of a aluminum oxide. So from there you can do the extraction of metal, means the electrolysis. Inert electrode are used in that purpose. Got it? Now for the non-inert electrode, non-inert electrodes are used in the electroplating and the copper purification. Basically, the word of a copper purification is eliminated from the syllabus, but still the type of a questions are came in your exam. Means the copper rods are used and the copper solution is used. So whenever a copper rod and the copper solution is used, that type of reaction is in their reaction, non-inert electrodes are used. Non-inert electrodes are those electrodes which are used up. They are used up during the reaction. Used up during reaction. Okay. Now, the next thing is the electrolyte here. Now, the solution is an electrolyte. Electrolyte is a substance that can conduct the electricity, allow the electricity to flow through it. You have two types of electrolytes. One are the aqueous form of electrolytes, and the second one is a molten form electrolyte. Okay, the molten form of electrolyte is used for the extraction of a metal. For the extraction of a metal, you will use a molten form of electrolyte. And for the in the aqueous electrolyte, cathode cathode will always give you the hydrogen gas against all the metals. It will Cathode will give you the hydrogen gas against all the all metals except except copper, silver, and the gold. If the copper, silver, and gold is present, then the solution will not give off hydrogen gas. The cathode will give you the copper, silver, and gold. The cathode will give you the copper, silver, and gold if the copper, silver, and gold salt is present in the solution. Clear? Then for the anode, is there any question? Then on the anode side of the aqueous solution, we are talking about aqueous solution here. Then for the anode side of aqueous solution, there are two types of solution. One is a concentrated, another is a dilute. So for the concentrated, always chloride and bromide will comes out, and for the dilute, the hydroxide ion will come out. The hydroxide ion will give you the oxygen gas, and the chloride will give you the chlorine gas, and the bromide will give you a bromine gas, and the other two anions sulfate and the nitrate. These will not come out from the solution. They will never come out from the solution. So this one is the introduction part of an electrolysis which I given to you. Now let's start with the question. Question number one. A student was investigating the electrolysis of a zinc chloride. Here's a zinc chloride electrolysis. So in the zinc chloride, they have not mentioned here the solution here. So what is the correct reason for the electrolysis not working? So what is the correct work? We have to check here. Now, solid zinc chloride has been used. This one is the correct answer. Okay. What is the correct reason? You have to check the correct reason here why the electrolysis is not working. The electrolysis is only work in the two state. One in a aqueous, another is a molten, which I have already mentioned here above. So the A is the correct answer here. The electrodes does not conduct electricity. This one is not correct. The power supply is not connected with the with properly. The power supply is connected here positive with the negative terminal. This one is not a big deal here. The crucible is too small to allow the flow of full flow ions. This one is also not a big deal. So the correct thing is here the solid. In the solid state ions are not free to move. In the solid state ions are not free to move. Okay. Now the next question is student sorry, solid lead to bromide is heated until it is molten, means it become in the molten state, means fused liquid form. The molten lead to bromide then undergo the electrolysis. Which substance are formed at the each electrode? Which substance is formed at the each electrode? First, the solid lead is converted into a lead bromide. PbBr2 is a solid. It converts into a PbBr2 as a liquid. Then electrolysis done. Electrolysis performed. So you have a Pb2 positive and the Br1 negative. Two ions of Br. So Bb2 positive, this will migrate towards the cathode terminal and the second one will migrate towards the anode terminal. So at the cathode terminal you will have a Pb here and the and the anode terminal you will have a bromine here. At the cathode terminal Pb will form and at the anode terminal bromine will form. Let's see. So now anode you will have a bromine, so we do not require the B and D here. Now we have to work on A and C. So the A is the correct answer here. Why? Because of a lead is produced here, not the hydrogen. This hydrogen is only produced in the aqueous solution. Yes, you memorize the ions like that you if you are belongs to the if you are living in the Lahore, so you are considered as a Lahori. Okay, or if you are living in a Karachi, so you consider as a Karachiist. Okay, so the thing is that the cations are known as a cation. Why? Because they are migrate towards the cathode. That's why they name are the cations. Got it? Now the next question. Question number 3. Here is a diagram. Acha, mostly whenever you have a diagram like this, in this diagram, the electrolysis of water is done. Na? Whenever you have a diagram like this. Okay. Now, The electrolysis of a concentrated, the word is concentrated here, that means the chlorine is produced. So they have already mentioned here that the chlorine is producing on the anode terminal and the hydrogen is producing on the cathode terminal. You have a concentrated hydrochloric acid here and the platinum electrodes are used as an inert electrode. In your course there are the two inert electrodes, one is a graphite, another is a platinum, graphite and platinum. Now, which statement describe what happens to the electrons during the electrolysis? Electrons, okay, all the things are mentioned here, means the question that can be answered for the what product will be produced at the anode, that is a chlorine, what product can be produced at the anode, that is a hydrogen, what type of electrolytes are used, that is a platinum or the graphite, what type of solution is used if the chlorine and hydrogen is produced, that is a hydrogen concentrated hydrochloric acid. So these I have made, right now I have made four questions here which can answer, which the examiner can ask, but he comes out of the way and asks the question very different way. He asks the flow of electrons. The electrons are always flow outside the circuit, outside, flow in wires, okay, outside the circuit means the wires. They are added to the electron ions, no. They are added to the hydrogen ion, no. They move through the circuit from a negative to positive, no. They move from a negative to solution, from a solution, sorry, one second. They move from a they move from they move through the solution from the negative. Solution is not our choice. Inside the solution the ions are move only, so the C is the correct answer here. They move through the circuit from negative to the positive. Got it? Electrons are basically moving from a negative to the positive terminal. Any question here? They are not added to the chloride ion. Chloride ion are already depositing. They are added to the hydrogen ion. One second, there is a mistake here. They are not asking for the flow of a yes. There is a thing is the flow of electrons are not mentioned here. They are added to the hydrogen ion. This one B is the correct answer. And I was considering this one. This was not correct here. The negative to the positive. The flow is from a positive to the negative. Anode will flow the electrons. The electrons will flow from a positive terminal from the anode and to the cathode. The electrons will flow from like this. As the chlorine will deposit, the chloride ion will deposit the electrons here. The electrons goes through here from the terminal. One second. Here are the chloride ions. They deposit electrons here, and these electrons move from the anode and they enters into the cathode, where the hydrogen ion gains the electrons and comes out in the form of a hydrogen gas. Basically, the hydrogen gas is filling in the tube. So I'm going to draw the arrow in the tube here. Got it? And the chlorine gas is producing in this tube. Now, next question. Question number 4. Concentrated aqueous sodium chloride can be electrolyzed. Which statement is correct here? Concentrated. We are using a concentrated sodium chloride here, which will be electrolyzed here. Okay. So if the concentrated sodium chloride, sodium will not be discharged. Hydrogen ion will discharge here. Hydroxide ion will not be discharged. Chloride ion will be discharged here. Hydrogen gas is formed at the anode, which is wrong. Hydrogen gas is formed at the cathode. So, and chlorine is formed, this one is wrong here. Hydrogen gas is formed at the cathode and the chlorine gas is formed at the anode. So, B is the correct answer. Sodium metal is formed never. Sodium metal is formed never. Sodium will not be formed in the case of a concentrated solution. Now the next thing. The diagram shows the electrolysis of a concentrated hydrochloric acid. We have a concentrated hydrochloric acid here, concentrated sodium chloride. So the concentrated hydrochloric acid will give you the hydrogen gas and the chlorine gas. Concentrated aqueous sodium chloride again gives you the hydrogen gas and the chlorine gas. At which electrode is hydrogen is produced? So the hydrogen is always produced at the cathode terminals. These are the two cathode terminals 2 and 4. So the correct answer is 2 and 4. Now the medium level questions. Which statement about the electrolysis is correct? Which statement about electrolysis is correct? Electrons move through the electrolyte. Electrons are not moved through the electrolyte, so the A is wrong here. Electrons move through the cathode in an external circuit. No. Electrons are moved through the anode. They are entering in the cathode. Negative ion move towards the anode. Negative ion move towards the anode in the external circuit. No. Positive ion move through the electrolyte towards the anode during the electrolysis. So which one is correct here? Positive ions are what? Cations. Cations move through the electrolyte towards the anode during the electrolysis. Anode is a negative one. Sorry, anode is a positive. So the positive and positive will repel each other. But there is written as a external circuit. Hmm. Ions always move in the internal circuit. Electrons move towards the cathode. Is the electron moves towards the cathode in the external circuit? Obviously, the sentence here is a sentence structure. Electrons move towards the electrode. This one is a correct answer here. Towards. Huh? So the electrons are moving in the external circuits and they move towards the cathode. Let me show from the diagram now. Here's the diagram. Okay. This one is a positive terminal. This one is a negative terminal. So the electrons again, electrons are depositing here. We are depositing an electron. These are moving towards the, this one is what? Sorry. I have make in the diagram. Let me do the correction here. This is negative and positive. So the electrons are moving towards the cathode. This one is a cathode here. Okay, through the external circuit. This here's the external circuit. This one is an external circuit. This one is an internal area. Okay, got it? Now, the next thing is dilute sulfuric acid. You have a dilute sulfuric acid here. Dilute sulfuric acid. So it will have a sulfate ion, hydrogen ion, then hydroxide ion. Okay, only these three ions will be present now. Now, sulfate ion will never be discharged. So the hydrogen and the hydroxide ion will discharge. Discharge means they're producing a hydrogen gas and the hydroxide is producing a oxygen gas here. Using an inert electrode, so there is a productions. So on the cathode hydrogen will be produced here. C and A is not our choice. The sulfur dioxide is not produced. Oxygen gas is produced, so the D is the correct answer. Any question here? Yes, beta. Now let's continue. Question number 3. Electricity electricity is passed through the concentrated solution. Electricity is passed through the concentrated aqueous sodium chloride. We have a concentrated aqueous sodium chloride, so the sodium will not be discharged again. Hydrogen will be discharged. Chlorine will discharge. Hydroxide ion will not be discharged. Inert electrode means the graphite electrodes are used here. Na? Now, so here is the diagram. Now, the products. Let's discuss which product are formed at the electrodes. So at the electrode, hydrogen will be formed here. Sodium will not be formed. Then you have an anode. At the anode, the chlorine will form here. Oxygen will not form here. A is the correct answer because the solution is a concentrated solution. Sorry. Question number 4. The diagram shows the electrolysis of a aqueous copper 2 sulfate. We have a aqueous copper 2 sulfate here. Now, aqueous copper 2 sulfate, that means the copper ion will be discharged. Copper ions are present, hydrogen ions, sulfate ions, and the hydroxide ion. As I told you earlier that the when the copper is present, so the copper will be discharged. Hydrogen will not be discharged. Hydrogen will not discharge. Copper will discharge here. Sulfate will not discharge. Oxygen will discharge here. Got it? As we are using a carbon electrodes here. If the carbon electrodes are not used here, if we use a copper electrodes, then the scenario will be different. The anode will used up and the cathode will will increases. We will the question will come. We will discuss in that question. Na? So the copper metal is deposited at the positive electrode. No, copper metal deposit will deposit at the negative electrode. In the external circuit, the electrons move from a negative to positive. Electron move from a negative to positive. Oxygen gas is given off on the positive electrode. D is the correct answer. C is not correct. B is not correct. Okay. Can you give me the explanation? Why the B is not correct? Hmm. Very good. Electrons move from a positive to negative. Good. Next. And electrons are not moved in the solution. Electrons are moved only in the external circuit. Now the next thing, concentrated aqueous sodium bromide solution is electrolyzed. We using a concentrated aqueous sodium bromide solution is electrolyzed using inert electrode. We are using inert electrode here. The ions present in the solution are potassium bromide, hydrogen, and the hydroxide ion. They have already give you the list of ions. To which electrode the ions attract to or during the electrolysis? They are asking for the attraction of ions. So the positive ions are moved towards the cathode and the negative ions will move towards the anode. So you have a positive ion, that is hydrogen and potassium, okay, and negative ion will move towards the cathode. Is this one is correct? No, C is not correct. We have the correct pair here, but the option is not correct here, na? So the correct pair here, the cathode positive cathode, sorry, potassium and hydrogen, they move towards the cathode. This one is correct, and these two are the negative, so they move towards the anode terminal. So the B is the correct answer here. Clear? Which which is the correct equation for the formation of a chlorine gas at the anode during the electrolysis of concentrated sodium chloride solution? So concentrated sodium chloride solution here, formation of a chlorine gas. We have to check the formation of what? Chlorine gas formation here, na? So the chlorine gas, they are in the negative form. The gas is produced, that means chlorine Cl2 is produced. So if 2 here, you have to place the 2. This 2 will increase the charge. Charge means the number of electrons. So the electrons will become a 2 positive here. So according to this equation, which equation is correct here? This equation number C is the correct answer here. Got it? Now, the hard questions will be a homework for you. I'm going